Hello everyone, welcome to Engineering Archives. Today we are going to look at our first practice problem for the chapter Co-planar forces. So the problem says, if the magnitude of the resultant force acting on the bracket is to be 80 pounds, directed along the u-axis, determine the magnitude of F and its direction theta. So before we start solving the problem, we need to set up the directions. So first I'll just draw the x and y axes, and then I'll just put directions. Alright, so the second step is to look at all the knowns and the unknowns given in the question. So we can see that we have this force that we have to find, the force F, and we also need to find its angle theta that it makes with the positive x-axis. And to solve, we will probably need of all the forces given. And in order to do that, we need the angles that they make with either the x or the y-axis. So in order to find this angle, we can use this detail given right here. So they have given us this right triangle, and through this triangle we can find this angle. Let's call it phi. Alright, so phi should be equal to tan of phi should be equal to the opposite side over the adjacent side, which is 3 over 4. In other words, phi is equal to 36.87 degrees. Now that we have this angle, we can easily resolve all the forces into their components and then add them to make two equations for the x and the y-axis. Let's continue with resolving forces into their components. So for the components along the x-axis, components along x-axis, and we should also draw the resultant force component that they have mentioned in the question, and it's supposed to be along the u-axis right here, and its magnitude is 80 pounds. So this is the resultant force vector. So what we will do is we will set up the x components of all forces equal to the x component of the resultant force. So let's do that. F cos of theta, this is the x component of the force F, minus 90 sine of 36.87. I put a minus sign since the force was in the negative x direction, plus 50 pounds should be equal to the x component of the resultant force, which is 80 cos of 45 degrees. Once we solve all these numbers, once we add them, the answer that we get is cos of theta is equal to 60.569. Okay, so let's leave this equation right here for now, and let's move on to the y components. Components along the y-axis. So f sine of theta minus 90 cos of 36.87 should be equal to negative 80 sine of 45. And once we solve these forces, we get sine of theta is equal to 15.431. Now that we have two equations for forces along the x-axis and forces along the y-axis, and we have two unknowns that are f and theta, we can easily solve for the unknowns. So let's isolate f in one of the equations. F equals to 60.569 divided by cos of theta. And now let's substitute this F into the other equation. 60.569 divided by cos theta multiplied by sine of theta is equal to 15.431. Rearranging this equation gives us sine theta over cos theta is equal to 0.254767, and this is obviously tan theta, so I'm going to skip a step. Theta equals to tan inverse of 0.254767. Theta equal to 14.29, and we can round this off to 14.3 degrees. Now that we have theta, we can easily solve for the force F. And so F would be equal to 60.569 divided by cos of 14.3, and the answer that we get for F is equal to 62.5 pounds. 62.5 pounds. So that's the simple procedure for this first learning problem. Thank you very much. See you in the next video.